Okay, here's our Chapter 4 review. Now, I want you to be sure that you have your formula sheets updated. I sent an email about Heron's formula and the area formula, so be sure you get those added to your formula sheet. Number 1, a triangle that does not contain a right angle is called an oblique triangle. Solving such a triangle means finding the lengths of the sides and a measure of the angles. Number 2. If A, B, and C are the measures of the angles of a triangle, and A, B, and C lowercase are the lengths of the sides opposite these angles, then the law of sine states that side A over sine A equals side B over sine B equals side C over sine C. You can use any two of these that you need to help you solve triangles. This is helpful. It's easy to use. Please be sure that you check your calculator for degree mode when you're working on these. We can always use the law of sines to find the missing parts of triangles in which one side and two angles are known. Question number 4. It says, solve the triangle. So here's what we know. The first thing I'm going to do is find angle B because I know the three angles have to add up to 180. So I found angle B. Now I'm going to use the numbers that they gave me, and I'm going to solve for side C first. So 10 over sine A is equal to C over sine of 81. And then it's algebra. I'm going to multiply both sides by the sine of 81. Be sure you put your calculator in degree mode, find the value of the numerator, divide it by the value of the denominator. I got 16.04. It said round it to the nearest tenth, which is 16. I used the same setup to find B, except I used the 61 that was actually a calculated number, and I got B to be 14.2. Question 5. Question 5 is the same as question 4. You're going to find your missing angle, you're going to use the law of sines, and you're going to find your missing sides, and I've got them listed here. Question 6. Two sides of a triangle are given. Determine whether the given measurements produce one triangle, two triangles, or no triangle. So here's where I start. I have a triangle. A is 70, side A is 8, B is 1, and there's C. And I'm going to start with 8 over the sine of 70 is equal to 1 over the sine of B. When I use my cross products, I'll have the sine of B times 8 is equal to 1 times the sine of 70. I'll need to divide by 8 on both sides. So the sine of B will equal this calculation. So when I calculate that, I get the 70. This is an old calculator, so I'm going to divide that by 8. Now what I have here is the sine. So I'm going to have to hit second sine on my calculator. And it's going to give me an angle of 6.74 degrees. Okay. Now, here's the deal. We're going to round that to 7 degrees. So it could be a 7-degree angle over here, or it could be a 7-degree reference angle, which would give me 180 minus 7 is 173, a 173-degree angle. Option A, option B. Now, let's go back. If angle B is 7 degrees, I still have enough room left to have an angle C. But if angle B is 173, I'm already over the limit when I add the 70 to it because the total has to be 180. So there is only one possible solution for the triangle, and it's 7 degrees for B. After you find that, I would use the law of sines and the fact that it's 180 degrees in a triangle to find the other angle. So I would subtract 70 and 7 from 180, and I get 103 here. And then I would set this up, and I would get C to be 8.3. Number 7, same type problem. Two sides and an angle are given. Determine whether the given measurement produces one triangle, two triangles, or no triangles. So A is 62. B, I don't know. C, I don't know. Side C is 6.6. So I'm going to use the law of sines. 12 over the sine of 62 equals 6.6 over the sine of C. So when I do my cross products, the sine of C is going to equal 6.6 times the sine of 62 over 12. I'll calculate that, and I will get my value for sine. So that's going to be sine of C is 0.48562, which gives me an angle of, let me pause this. So I'm going to get an angle of 29 degrees. Okay, so we're going to talk about the same thing. Could be this angle, could be this angle. And 180 minus 29 is 151. So these are my two options. Well, let's talk about it. If I use 29, I got room for another angle. If I use 151 and I add 62 to that, I've already exceeded the 180. So I'm not going to have this. It's going to be 29. And then I'll go through the law of sines and the fact that a triangle adds up to 180 to find the other parts. Question 8. Find the area of a triangle. You're just going to plug that into your area formula. Be sure you add these to your reference sheet. Round to the nearest whole number. Number 9. Find H. So H is this side. I'm going to need to know A. This is a right triangle. I'm going to use sine here in a second, but I'm going to need to find A. So I'm going to need to focus on this triangle. And so I will have C. I'm going to find C. I'm going to do 180 minus 32 minus 110. It's 38. And then I'm going to use the law of sines. 373 over the sine of 38 equals A over the sine of 32. So that gives me 321 for this value. Then I'm going to redraw that right triangle. And I'm going to use sine. The sine of 70 is equal to H over 321. Now that H does not mean hypotenuse. It's the height of that triangle. But we're using opposite and hypotenuse when we find our sine. So we find that to be 301.69. Round to the nearest tenth. It's going to be 301.7. Number 10, a tower leans 84.7 degrees. Figures shown is 182 feet from the base. Find the distance from the base to the top of the tower. We're using the law of sines. 11, law of cosines. Go to your reference sheet. It's on there. You just pick out the right formula. Number 12, to solve an oblique triangle given two sides and an included angle, The first step is to find the missing side using the law of cosines, and then we use the law of sines to find the angle opposite the shorter two sides. This angle will always be acute. The third angle is found by subtracting the measure of the given angle from the second step, and you're going to subtract from 180. Heron's formula, remember we've added this to our reference sheet, so this should be an easy question. And then they're asking you to use the law of cosine. So they're giving me A, B, and C. So I'm going to start with B squared equals A squared plus C squared minus 2AC cosine B. I'm looking for B. That's the first thing I'm looking for. So I'm going to plug my values in and just go through the algebra, and then I'm going to use second cosine, and I'm going to get 69 degrees for angle B. Then they want you to use the law of sines to find the other ones. However, in this particular triangle, it's isosceles, so you know that this is 69 and this is 69. Then we can subtract from 180 and find that this is 42. Question 15. Solve the triangle, same thing. Use what you're given. Since I'm given angle C and side A and side B, I chose this version so that I could find side C. I plugged it in. I carefully did the calculation, took the square root. I got 3.1. Then I used the law of sines and I found my angles. $16, same thing. You're just using what you know. Same thing on 17. 18 says use Heron's formula to find the area of the triangle. First thing you have to do is find S. It's easy. It's half of the three side lengths added together. And then you just multiply S times S minus A, S minus B, and S minus C. Calculate that and we get approximately 3 feet. Find the distance across the lake from A to C. This is looking for B, and we're going to use the law of cosines here. Be careful when you calculate, and you're going to have to take the square root. Don't forget that. Next, we're going to talk about vectors. Vectors are super easy. A vector is a quantity that has magnitude and direction. We refer to the figure at the right, which vectors are equal. Well, they're going to be the same length going in the same direction. So you're just looking for two that match. Pretty simple concept here. The horizontal component is A, the vertical component is B, and the magnitude is given by the square root of A squared plus B squared. And you can add this to your formula sheet as well. This is like an ordered pair for a vector, but it's kind of, it's V-shaped instead of parentheses because it is a vector. And the initial point's at the origin, then the vector is a positive position vector. It's a position vector. It tells you where it's located on the coordinate grid. Okay, these make sense. If you're adding two vectors together, you add their horizontal components and you add their vertical components. If you're subtracting, then you subtract same way. And if you're multiplying by a scalar, you multiply the same way. So solve or sketch the vector. This is a vector that's going to start at the origin and it's going to go through the point 5, 1. And the only one of these that does that is right here. And the magnitude, well, that is the square root of the A value squared and the B value squared, and the B value here is 1. So we get the square root of 26. Let V be the vector, and with the initial point P1 to terminal point P2. So it's going from here to there. Write V in terms of I and J. So what we're doing is we are subtracting. We're going, how far did we go? We started here and ended here. So -6 minus -8 is 2I. 9 minus 2 is 7J. We're adding here. 8 plus -9 is -1I. -2 plus 7 is 5J. We're subtracting here. Please subtract in the right order. And in the last one, we are finding the magnitude, and then we're multiplying that by 4. So we're doing A squared plus b squared, and then when we take the square root, we're going to multiply that by 4. Hope you do great.